Hi guys, welcome to a physics tutorial. Today I'm going to be going over the 2017 NCEA Past Electricity paper. So let's begin. Question 1. Electrostatic speakers. Sam has recently purchased this and between two conducting plates that are 3 centimeters apart. The first thing I'm going to do is anytime I see a value in the incorrect unit, I'm always going to convert it to the right unit. So 3 centimeters converted to meters is going to be 0.03 m. A simplified diagram of the speaker is shown below. The plates are connected to a 6 kilovolt, so that's also not in the right unit, so it's going to be 6,000 volts. High voltage DC power supply, show that the strength between the plates is 2 times 10 to the 5. So they've already given us the answer. We just need to show how they got to that. So the formula on your equation sheet for the electric field strength should be E equals V over D. Substituting our values, the voltage here and the distance there. So we're going to get 6,000 divided by 0.03. If you put that into your calculator, you will get 200,000 voltmeters, or the same as 2 times 10 to the 5. Same thing. You will be awarded and achieved if you get this right. Next question. The initially neutral diaphragm centrally placed between the plates is charged by adding electrons onto it. Okay. Calculate the total charge and the size of the total force, including direction experienced by the charged diaphragm. So we've got a couple of things we need to do. We need to find the total charge, then we need to find the size, and then we need to find the direction. Okay, so the total charge, we're going to write that as Q equals N, which I'm just going to call this number of charges, which we are given above, which is this here, the 3.7 times 10 to the 12. That's how many electrons there actually are, times the individual charge on an electron, which is on your formula sheet. It should be like 1.6 times 10 to the 19, if I can remember, times that. These are the same thing, it's just this, I've read it as a big Q because that represents the total charge, whether this is sort of the individual charge. So that's going to equal 3.7 times 10 to the 12 times 10 to the 12. 3.7 times the charge negative 1.6 times 10 to the 19. And that should equal negative 5.92 times, let's just put in my 7. Okay, and then once we have our sort of total amount of charge, we do still need to find the size of the total force. So the force is F equals EQ. This right here is actually this. Now I know there's also a little q here, but just bear in mind I've represented this as the large Q because that's the total amount of charges. I can write a capital Q here as well, but I just want to stick with the formula. So that's going to equal the electric field strength, which was 2 times 10 to the 5. 2 times 10 to the 5 times what we just found, negative 5.92 times 10 to the 7. If you put all that in, you should get equals 0.118 newtons. I've just made it positive because I don't like having a negative result. And we're not done yet, so we've found the total charge, we've found the size, we still need to find the direction. It's really easy to tell. If we go back to this diagram, we can see that this here, this positive that means this is the positive side. So that means the electrons here, electrons get attracted to opposite charges. So they're going to flow towards the positive plate, which means the direction will be to the right. So I can write direction of the total force is towards the positive plate. Just add some detail. Don't have to write this, you can just say it goes right, but I just want to add some detail towards the positive plate. So right. Alright. This is a merit level question. If I look at the schedule, correct answer and direction, so correct force and direction, so this whole section here will get you a merit. For achieved, it's the correct charge, so this is achieved, or the correct direction or correct force, so any one of the three. Next question. A uniformly charged diaphragm is fixed at the top and bottom to smooth sliders, which allows it to move to the left or right by a total distance of 1 centimeter. I'm just going to change that to this immediately. Explain why the size of the force on the diaphragm remains constant and no bending occurs as the diaphragm moves within the sliders. Okay, so we're focused on this thing here. Now what we need to think about are our formulas, because they're talking about the size of the force. Give me a sec, someone's calling. So if we think about our F equals EQ formula, we know that the electric field strength doesn't change. So we know E is constant. Now, and the charge is obviously constant as well. So now, since these two are constant, we already know that the force is going to be constant, but we can elaborate on that a bit more. So the force is going to act uniformly, which means there's the same forces everywhere, okay? Evenly distributed throughout, which basically means each part of the diaphragm is going to have a constant force throughout, no matter where it is within the field. It's always going to be the same, which basically means no bending will occur, because for the bending to occur, the force needs to change, or at least, either increase or decrease. So we can write something like force F equals EQ remains constant throughout since E stays the charge evenly distributed. Don't know how to spell that, whatever. And then we're going to answer the question fully by linking back to this bending. This means no bending will, oh no, what's happening? Will happen because the force doesn't change. Alright, that's all you need. Talked about the force not changing because the E remains constant and the charge remains constant and evenly distributed throughout. So that means each part of the diaphragm is going to experience the same force no matter where it is, so that means no bending will happen because the force doesn't change. So for merit, you need to talk about the electric field strength being constant, and you need to either say the charge is constant and link it to the bending. So you need this statement here and this for merit. For achieved, it's just electric field strength is constant or uniform distribution of charge linked to bending. So just up to here can get you on achieved. Pretty generous.